A new left-hand rule for Faraday's law of induction is presented. This rule can be used for finding the relations between the directions of the variables of Faraday's law without using Lenz's law. Hand rules have been used in electromagnetism for over 100 years. They make it easier to find the directions of variables of the fundamental laws. For example, Ampere's law and Lorentz force. The directions of the variables of Faraday's law are usually found by applying Lenz's law, which is not as easy and simple as applying a hand rule. I prepared the hand rule for Faraday's law, and here it is. Align the curved fingers of the left hand with the loop of the conductor. The stretched thumb represents the normal to the surface enclosed by the loop and defines the positive direction for the flux. If the change in flux delta phi is positive, the direction of the induced electromotive force is the same as the direction of the curved fingers. If the change in flux is negative, the direction of the induced EMF is against the direction of the curved fingers. This example illustrates how the left-hand rule is applied. A magnetic field that is decreasing with time is pointing towards us, left side of the figure. What is the direction of the induced EMF? The left hand is set as in the right side of the figure. We could have set the hand so that the thumb would point away from us, and that would have been okay. But once the left hand is set, the initial and final fluxes have to be calculated with respect to the direction of the selected normal, the thumb. We have to find out whether the change in flux is positive or negative. The angle between the magnetic field and the normal is 0, so cosine theta is 1. Therefore, both the initial and final fluxes are positive. Since the magnetic field is decreasing with time, the change in flux is negative. According to the left-hand rule, the direction of the induced EMF is against the finger's direction, namely counterclockwise. This formula expresses Faraday's law in integral form. The line integral on the left is the induced EMF, and the surface integral on the right is the rate of change of the magnetic flux. The relationship between the direction of the normal n and the direction of the integration along the line integral is as between the right thumb and the curved right fingers. The minus sign on the left side is equivalent to changing the direction of the line integration, hence the left-hand rule.